So now we will see the syntax of operator overloading. Okay, so the syntax is the name of the class. Okay, so the name of class followed by operator. Okay, operator keyword. So this is very important. So this is a keyword that you have to remember. So whenever we are doing operator overloading, so this keyword must be introduced. Okay, next is the type of operator that we are going to overload. Okay, and next is inside this. Okay, so what will be passing will be just passing the name of the class and followed by its reference. Okay, so this is, you can say, the syntax of operator overloading. So we'll just see this syntax. Okay, we'll just break this syntax with the help of a program. I will just demonstrate you. So in the previous program we have just seen, when we covered the concept of returning and passing the objects, okay, as an arguments. So we have just created a program in which we have just created uh, two objects, okay, in which we have just passed some values. Okay, so for example, this is of type complex. So I'm just taking an example of the complex numbers only, so that it could be easy for you to understand. And the second object contains the value 30 comma 40, and again I have just created a third object. And in order to achieve the addition, okay, so that this 10 must be added to this 30, or the real part must be added to the real part of second object, and this 20, that is the imaginary part, must be added to the imaginary part. What we have done, we have just written it like that: c3 is equal to c1, okay, dot, and we have just created a function add, and inside this function we have just passed c2 as an argument. So this we have done. Now in the same way, okay, now in the same way, what we have to do, okay, in order to achieve this, now I am not using this add function. I am not creating any added type of function. Instead of adding, creating any functions, I'll be using the concept of operator overloading. It means now I can do this task directly. Okay, now I have to invoke, or I have to process this task. Okay, so now I have to make this statement as a valid statement, because previously this statement was not considered as a valid statement by the compiler. Why? Because both C1 and C2 are non-primitive, and for non-primitive it is very difficult for the compiler to understand that how they can be added or how the operation can be performed. But now we will just perform the operations. Okay, so we will just write, okay, it like this. So now you have to, okay, just cut it down. Okay, so now instead of this, what we'll be doing, we'll be using C3 is equal to C1 plus C2. So in order to, okay, in order to invoke this, and at last what we have to write, we have to just invoke c3 dot show. Okay, so that the addition must be performed. So this is a rough pseudocode I am just, okay, writing here. I will be just training the program after this particular session. Okay, so you have to just remember that this is inside main. Okay, so this all thing is inside main here. So inside main I have just created, okay, complex type objects, and in that particular objects we have assigned certain values, and we have directly performed the operation like c3 is equal to c1 plus c2 instead of using any function. Okay, instead of using any function. So let us try to see that how this particular call will be resolved by the compiler. Okay, so in order to resolve this call, okay, so the compiler will treat this particular statement as, okay, so for the compiler this particular statement will be, okay, will be considered as c3 is equal to c1 dot operator, okay, operator plus, and inside this is an argument. So this call, okay, this particular call will be resolved by the compiler like this. So compiler will understand it like this. So for the compiler, okay, so for the compiler it will be resolved, or it can be processed like c3 is equal to c1 dot operator plus c2. So here you can just see, if you just compare it, if you just compare it with the previous syntax, that c3 is equal to c1 dot add, and in this we are just passing c2. So what is the difference here? Okay, the main difference is now we have just replaced this add. We have replaced the name of the function add with the operator plus, okay, operator plus type of statement. So now add has been replaced by operator plus, and whole thing is same. There is no change in the coding. Okay, there is no change in the coding, just the syntax has been changed. Why the syntax has been changed? Because now we have to perform the non-primitive addition. Okay, so I am just changing the name of add to operator plus because I have to perform a binary addition. I have to perform the addition of two complex numbers. Okay, so now you can just correlate it. Okay, so what you will be doing? Okay, so what will be the definition now? So the definition will be, okay, because it is returning a complex type of object, so the return type must be complex. Okay, so you have to just, okay, think it logically. The return type is complex, and after this what we write, we just write the name of the function. Okay, if you have just seen the previous program, so what we write, we just write the name of the function here. But now there is no function name, so in spite of writing the function, what we'll be writing, we'll be writing operator. Okay, we'll be writing operator plus, and inside this what we'll be writing, we have just passed C2 as a reference. So we'll be just taking the reference of the complex class, and we'll be just writing complex ampersand c. Okay, so now you can see the statement is similar. Okay, there is no change in the statement, there is no change in the syntax, only we have just replaced the add with this operator plus. Okay, so now there is also a new definition that has been evolved. So it can be said that operator overloading is a process of using an operator instead of a function to do a task. Okay, so we can say that operator overloading, okay, operator overloading is a process. From this particular syntax we have just derived a new definition. It is a process of using, okay, an operator, an operator instead of a function. Okay, instead of a function to do a task. Okay, so this is very easy to remember also. Okay, there is no problem in understanding this type of concept. Whole concept is same, just we have replaced this add with this operator plus. Okay, because we are going to add two numbers. If we have to subtract two numbers, then we have to replace, okay, this definition part with operator minus, so it will be a binary subtraction. So now this is the definition. So what I'll be writing in this definition, okay, there will be no change in the logic. So again I'll be just creating a complex type of object, that is complex temp. Okay, and we'll just writing temp dot a is equal to a, because this a will be passed implicitly. Okay, because for the compiler, okay, for the compiler I have told you that C3 is equal to C1 plus C2 is equivalent to this particular thing. Okay, for the compiler it will be resolved as C3 is equal to C1 dot operator plus C1 is the caller object. Okay, so C1 is invoking operator plus, C1 is invoking operator plus, and inside this operator plus we have just passed C2 as an argument, and the result will be returned to C3. Okay, in the same way that we have processed the previous question. So now C1 is the caller object. Okay, so caller object is invoking the function. So now this operator plus is behaving like a function in which we have passed C2 as an argument, and the value will be returned to C3. So the thing is same, there is no change here. So what I'll be writing, I'll be writing a plus c dot a. Okay, because this a will be passed implicitly. This a is a of c1 and this a is a of c2 that we have passed as an argument. So this is of c2 and this is of c1. So this is implicit, this is we have passed directly, and this is explicit. Okay, this is explicit because this we have to access with the help of the reference of the class. We can't use it directly. And again we'll just write temp dot b is equal to b plus c dot b, and we'll just return temp. So this is it. Okay, so So this temp will be returned to C3. Okay, where we have returned C3 is equal to C1 plus C2. So this will be returned to C3. So now we can just write C3 is equal to C1 plus C2. Now it will be treated as valid because we have overloaded the operator plus. We have overloaded plus operator with the keyword operator. Now the non-primitive addition is possible. Okay, so now we'll just see the syntax. Okay, so this syntax is okay valid also. We have just seen that the syntax is complex, that is the name of the class. Okay, second is okay, this is the return type also. The name of the class is the return type. Second is the operator plus keyword. Okay, and the third is we have to pass in the common bracket the name of the class and its reference. So it is okay, it is similar. Okay, so this is the name of the class. Okay, or you can say it is the return type. Okay, so name of the class is the return type here, and operator and the type of the operator. But we are okay, but we have overloaded plus. So here it comes complex operator plus, and name of the class is complex and its reference. So that reference that we have created. So this is the definition. Okay, you can also declare it inside the class, and you can also define it outside the class with the help of scope resolution operator. So we can use scope resolution operator to define this operator plus outside the class also. Okay, but in friend function we can't use scope resolution operator because friend function is a non-member function. So I hope now it is clear to you. So we'll be implementing it with the help of a program in the next session. Thanks.